Our last video, our last couple videos, we learned how to use the quadratic formula, where it came from, and then we learned about the discriminant. So we're just going to do some practice problems to kind of help that sink in a little bit. However, I'm going to change it. It says solve the equation using quadratic formula. I'm just going to change it to solve the equation, because one of the things we like to teach our students is, you know, several methods to solving quadratics: square root, factoring, quadratic formula, and complete the square. And one of the things we like our students to practice is to figure out which method is most efficient. So if I was looking at number 1, because this is a 1x squared, the first thing I'm going to do is I'm going to see if this factors. So I want to know if there's anything that makes negative 18 and negative 7. And there are. We can use negative 9 and 2. So this actually factors into x minus 9, x plus 2. So my two answers are going to be 9 and negative 2. So factoring is actually way less work than the quadratic formula, and we're always trying to look to make our lives easier. For number 2, we can't even begin it until we have the problem equaling 0, and then we'll have to assess which method would make sense to use. So right now, I don't think this is going to factor because there's nothing that multiplies to 1 that adds to negative 4. So it would be nice if it would factor, but it doesn't. So we're going to have to either use quadratic formula or complete the square. So it doesn't matter which way you want to do it. Personally, I would probably complete the square because I know that 4 is a very friendly number to work with when we're cutting things in half. So I'm going to go ahead and I'm going to move this 1 over, and we're going to add b over 2 squared. So 4 over 2 is 2. When you square it, you get positive 4. So then this factors very nicely into w minus 2 squared, and you get 3. And really, I can wrap this up in 2 steps. I can take the square root, so it'll be positive negative root 3, and then all I have to do is add the 2 over, and I'm done. So for me personally, I can complete the square faster than use the quadratic formula, so I'll probably go with that method if my numbers are nice and friendly and small to work with. And then last but not least, we have 4z squared minus 7z plus 3. So I want to make sure that I have everything equal to 0, and it doesn't matter if you move over, you know, the 4z squared and the 3, or you can move over the 7z. It's not going to make a difference in the grand scheme of things. You're going to get the same answer regardless. But teacher preferences, we usually like the z squared term to be positive. That just, it looks more normal to us, so that's what we'll go with. So we could try to see if it factors, but because a is not 1, we're going to have to factor by grouping, so it's not going to be as short as the factoring we did for number 1. And I definitely wouldn't complete the square because you're going to have to divide everything by 4, and now you're going to have to work with 7/4, and kids usually don't like to do that, so I don't blame you, teachers don't either. So I think I'm going to jump right to the quadratic formula. So we have negative b, which would be 7. We have plus or minus the square root. B squared would be 49. And then we have minus 4ac. And it would all be over 2a, which would get you 8. So if I do 4 times 4 times 3, I get 48. And 49 minus 48 is a nice pretty 1. So the square root of 1 is just 1. So either my answer will be 7 plus 1 over 8, or it'll be 7 minus 1 over 8. I have to consider both scenarios. So this will become 1, and this will become 6 over 8, which is 3 over 4. So these are my two answers for x, or well, for z in this problem. For 4 and 6, it says find the discriminant. So discriminant means b squared minus 4ac. It's the radicand of the quadratic formula. So I'm going to set up all my discriminants first. So we have to do 34 squared minus 4 A is just 1, so I'm just going to use the C because multiplying by 1 doesn't change anything. For 5, really, even if you think you're that good at math, it's always a good idea to write out what you're going to do. So I'm going to move the 8x and the 3 over. I need this to be equal 0 before I can even start to find the discriminant. So b squared is 64 minus 4. And a is just 1 again, so I'll just use the c term since 1 doesn't change anything. And then one more time, we're going to subtract 3q, get this guy equal to 0, and then we're going to do that b squared minus 4a, and this time c is 1. I don't need to write times 1. That doesn't change anything. So if I were to touch this on a calculator, I should get 0. This would become 64 plus 12, which is 76, and 9 minus 16, which is negative 7. So we found the discriminant of each, and then we have to use that to say how many solutions and what type they are. So if you look back to your chart from the previous video, we said that if the discriminant is 0, that means 1 real solution. And if the discriminant is positive, that means 2 real solutions. And if the discriminant is negative, that means 2 imaginary solutions. So I know before I even use the quadratic formula that these should be the outcomes of each of these problems. Our last problem is a word problem, and these are the most common problems that we see. So we're going to jot down some formulas to help us along the way. And if you recall, in past lessons, we've done some dropped object problems, and this is the formula for it. So we have how fast the object is being pulled due to gravity, and then the starting height. If you follow this formula, you can get the height of a dropped object based on how much time has gone by. So we're going to introduce launched objects. So if I throw a ball up into the air, or if I tilt a cannon down and shoot it down at the ground, we're going to use these formulas. So they're almost identical. It's just if something is launched upwards, we use plus, and if it's launched downwards, we use minus. And then V sub 0 stands for initial velocity, and h sub 0 stands for initial height, which is also called the y-intercept. Oops, I'm going to have to move this over because I cannot see. There we go. All right, so we're going to take the info and we're going to set up a formula for part A. So the baseball player hits a foul ball straight up in the air from this height, and here's the initial velocity. So we're going to take those values, and since it's hit upwards, we want to use this formula right here. So we begin with h of t, and we have negative 16 t squared plus 85t plus 4. So that's going to be our formula. All right, next they ask, well, okay, using this formula, when would the ball be that high off the ground, 110 feet high? So if we're given height, we want to substitute that in for the height side, and then we're going to solve for t. So we're going to substitute 110. It's always a good idea to get your quadratic equal to 0. And when I have like really nasty kind of big numbers, especially with negatives, I'm going to use the quadratic formula. It's probably the easiest way to go. So we'll set up our negative b plus or minus square root b squared minus 4ac all over 2a. And I would just punch this whole radicand right into a calculator exactly as I see it. And when I square root that answer, I get 21. So it actually does work out to be a perfect square. And then we have to divide it into two cases, negative 85 plus 21 and negative 85 minus 21, which is going to give us the answers 2 seconds and roughly 3.3 seconds. So there's actually 2 answers to this problem. And when I get 2 answers, I just want to run it through and make sure those answers both make sense. So they're asking, well, when is it that high off the ground? And if you think about the situation, okay, the batter is hitting it from a height of 4 feet. which means 110 would be way up here somewhere, right? So that line represents 110 feet. When you hit the ball, it's going to go up, and then it's going to fall down. So this would be the 2 seconds, and this would be the 3.3 seconds. So yeah, both those answers make sense because there are 2 times when the ball is going to be that high, once on the way up and once on the way down. So we're going to keep both answers as they both make sense. Letter C talks about a catcher catching the ball. So you're still given a height, so you might as well put 6 in for the height. All right, and then we're going to go ahead and solve, and then we'll ask ourselves, do our answer or answers make sense? So we'll move that 6 over. We'll set up our quadratic formula again. It's not so pretty this time. You end up getting roughly like 84.24, something like that. And if you break it into case 1 and use the plus, you'll get 0.02. If you use the minus, you'll get 5.2. Now here's the only thing. So we go through the math and we do our computations. That's really not the hard part. Now we have to assess, do our answers make sense? So the catcher catches the ball 6 feet from the ground. So again, if we think about scenario-wise, here's the batter's height and here's the catcher's height, right? And the ball gets hit. It's going to go up and it's going to go down. All right. So if the question said, when is the ball 6 feet from the ground? Then you would take both answers because it's on the way up and the way down. But we're basically saying, well, the catcher caught the ball. Well, the catcher can't catch the ball twice. So would he have caught the ball right here or would he have caught the ball right here? And logic dictates he would have caught the ball after 5.2 seconds. So that ball would have been in the air from 0 to 5.2 seconds. So we want to keep the 5.2, but we're going to reject this answer again because the catcher can't catch the ball twice. So you do have to take your answers and then think about the question, think about the picture of what's going on, and you have to ask yourself, do both of my answers make sense or is it just one of them makes sense? Again, because it's a word problem, to make sure your answers make sense in the context of the problem.